Aloha, good afternoon. So nice to see all of you here. I'm sure we'll still have some folks traveling in here, but we have a big full presentation from our incredible presenter today. So I want to make sure and get the stage over to her. So welcome. My name is Thomas Dalbert. I'm the Executive Director of Friends of Hawaii Wildlife Refuges. And it's my pleasure to welcome you to our Princeville Moʻolelo series. We're kicking off for the year 2025. And of course, this is a partnership between ourselves and the Princeville at Hanalei Community Association, which is offering this beautiful space we're in today. So we appreciate that collaboration. A quick plug for who we are, if you're not as familiar, and I see some new faces here, which is always exciting. We are the Friends group that helps support the 3 national wildlife refuges that are located here on the island of Kauai. Hanalei, Huleia, and Kilauea Point are the spaces that we help preserve and protect. And the why. Why are we here? We are here to help preserve and protect the endangered seabirds and water birds that need our protection, and the spaces that were set aside to help keep them safe. So that's what we're here to do. How do we do that? We provide funding, in-kind staffing support, and community outreach like we're doing today, bringing our community together to learn about all the different aspects of helping to keep our island safe. So there are just a couple of quick programs that we generally do to help support that. Basically, the refuge comes to us and asks for money. There are places where they need our help, some aspects of their budget that need a little bit more funding, and that's where we get to show up. Thanks to the love and generosity of our community through nature store sales and fundraising, we help support habitat maintenance and native plant restoration, all kinds of good stuff, directly helping to underwrite the mission of Fish and Wildlife. We go out into the community and talk story and help educate folks about what we do. And one of the things I'm really proud of is we help underwrite the cost of care for all of the birds that are transferred from one of our 3 refuges and into the expert care of our partners at Save Our Shearwaters. And you all help make that happen. We as well help support environmental education. We have a number of the volunteers here in the room today that are helping to educate tomorrow's conservationists. And we provide free buses for field trips out to Kilauea Point. So those are a couple of ways on one end of the spectrum. On the other end, each year we provide scholarships for young people that are studying in conservation-based careers. And this year we're expected to give away $30,000. So we are really excited to continue the momentum of supporting young people who are going to just have immeasurable impact across our islands. The best ways to help support us are sign up on our newsletter. If you're not already receiving our notifications, please sign up in the back of the room there and you'll be advised of future talk story sessions like this, as well as all the great work that we're doing. For those folks online, if you click on our website as well, there's an opportunity for you to do that. And just a reminder for us, we are recording this as a Zoom session today. So please be mindful of your background noise as we're all trying to share the space with the folks online. Wanted to give a quick plug for another collaboration that we are participating in. We are working with the incredible folks at the Garden Island Arts Council to produce a beautiful new mosaic mural project that is coming to Kilauea Point. It's a cultural program sharing information and talk story, and at the same time working together to create this beautiful new mural that's going to grace that walkway, that retaining wall on the way out to Kilauea Point. And we're doing that by volunteers coming together and actually help to create the mosaic mural. It's a really great project to collaborate with perpetuating the art form of mosaic art making and learning the story of this the geographical and cultural and wildlife story of how all of these islands across the whole archipelago, from Kure Atoll all the way out to the Big Island, are all interconnected. And it's a really neat way for us to use that space to host that story. So if you're interested in learning more about it, this, like I said, is produced through workshops in the community. If you sign up for our newsletter, we're going to be announcing them as they come up. And the next one, in fact, is being hosted this Saturday, the 18th, by Malama Huleia, our partners at the other side of the island there. So if you're interested in more information about that workshop and getting your hands into that project, let me know and we'd be happy to share that with you. A couple of quick updates as well. If you've been at Kilauea Point recently, you've started to see some construction happening there. And so we just want to let the community know that the overlook right at the very entrance of Kilauea Point is currently closed, as they're doing work to stabilize that shelf there and make it safe for humans and traffic and the wildlife that depend upon that shelf there. So between now until the middle of February, that overlook right at the entrance to Kilauea Point is closed. After the 17th, Kilauea Point itself was going to be closed for several months while we do some major restoration work to the entrance roadway, making it safer for traffic, pedestrians, and water flow throughout the refuge. Much more information to come, but we want to start putting that out there to our circle of friends that we're going to be having some big impacts to our operation for a couple of months. But it's all to come through that to be bigger and better and safer. So hang in there with us. Okay. The next in this series, our guest is actually in the back of the room here. On February 11th, this series will continue talking all things moly with our dear friend Hawaiʻi. So please come back on Zoom or here in the room on February 11th, and we'll be doing a great conversation with our dear friend Ha. With that, like I said, we have so much great information by our dear friend Jean Souza, Program Specialist with Hawaiian Islands Humpback Whale National Marine Sanctuary, National Oceanic and Atmospheric Administration. I actually got it out. We are delighted and honored to have you join us. Please give a warm round of applause to Jean. Thank you, Jean.
Super. Aloha kako. It's great to be with you, all of you today in person and online. It's probably been about 6 years since I have presented a comprehensive overview of Hawaii's humpback whales. There is a lot to talk about. And in the interest of time, I hope you will allow me to use my extensive notes in this presentation. With any living thing, whales included, conditions change, sometimes in drastic ways. Those changes, as you will soon learn, can affect population trends, migrations, communication, and also what we thought we knew about feeding behavior, mating behavior, threats, and recovery. To those who have heard me speak about humpback whales before 2019, be prepared to make a big shift and adapt to the new information I will be presenting today. Before we get into proper introductions and the PowerPoint and video clips, I'd like to spend a moment getting to a better sense of the size and mass of a humpback whale. So if we had a live adult female humpback whale in this room today, the head or the rostrum would be here, and the tail would be out the door to the near edge of the parking lot. Okay, 45 feet in length. We couldn't even fit the width of the body here with its pectoral fins stretched out. We would only be able to accommodate half the body here with the 15-foot pectoral fin on the right side to that window. Okay, so the main body would be here, and then the left pectoral fin would be out there. Okay. 45 feet in length, about 40 tons or 80,000 pounds. I'm Jean Souza, Program Specialist with the Hawaiian Islands Humpback Whale National Marine Sanctuary. I find that making it a sing-song makes it easier to say. Part of your federal tax dollars are allocated by Congress to NOAA. Thank you very much. NOAA includes the National Weather Service, National Marine Fisheries Service, and National Ocean Service, which encompasses the national system of national marine sanctuaries and national marine monuments that protect marine and Great Lakes resources. Most of you are familiar with the National Wildlife Refuge System, which is part of the Department of Interior. National Marine Sanctuaries, which I represent, is in the Department of Commerce. The Hawaiian Islands Humpback Whale National Marine Sanctuary was established by Congress, designated by Congress about 30 years ago to aid in the recovery of humpback whales since Hawaii is the only state where they breed, calve, and nurse their young. As you will remember, the humpback whale population was severely decimated during the commercial whaling era, as were other great whales such as right whales and sperm whales. The boundary of the National Marine Sanctuary encompasses portions of all of the major Hawaiian islands. On Kauai, the boundary stretches from Mokulea Point in Kilauea to Kailio Point in Haena, and from the shoreline to the water depth of 600 feet. Our staff, which is among the smallest in the National Marine Sanctuary system, is based primarily in Kihei, Maui. The waters there attract the highest density and highest population of humpback whales that return to their birthplace during the Northern Hemisphere breeding season. One of my responsibilities is to manage Kauai Ocean Discovery, a free public ocean learning center in a storefront space at Kukui Grove Center in Lihue. I'm focused on outreach and education, recruiting and training volunteers, and assisting in whale emergencies. I'm not a whale researcher, though I do interpret research activities and research findings for the general public, hence my presence here today. Big mahalo to the Friends of Kilauea Wildlife Refuges and the Princeville Community Association for inviting me here. Dr. Mark Lammers, who is based on Maui, is the research ecologist for the Hawaiian Islands Humpback Whale National Marine Sanctuary and leads the research program. His specialty is marine acoustics and marine mammals. This presentation is an adaptation of one of Mark's presentations that he gave a few months ago on Maui. The graphics he used to share some of the latest research tools and findings were so outstanding that I wanted to share them with all of you since he's not able to be here in person during the peak of the humpback whale season. The Sanctuary program has its foundation in three main areas: resource protection, such as response to large whales and life-threatening entanglements that Ed Lyman leads, and also includes the health and risk assessment work, trying to understand the overall health of humpback whales. Education and outreach, such as Kauai Ocean Discovery and our visitor center in Kihei, Maui, Sanctuary Ocean Count, and special events that I handle. And then there's research led by Mark. Research activities can broadly be divided into three general areas. One is acoustic monitoring, which we will talk about in a little bit. Another is whale behavior studies, meaning understanding more about whale behavior and how it relates to their conservation. And lastly, various types of surveys from vessels and from shore. I won't be talking much about that today in the interest of time. We will be focused primarily on acoustic work and the behavior studies. Very broadly, humpback whales are found in all of the world's hemispheres: Northern Hemisphere, Southern Hemisphere, Western Hemisphere, Eastern Hemisphere. They are designed to take advantage of seasonally abundant food resources. With the exception of a small stationary population in the Arabian Sea, all subpopulations of humpback whales migrate great distances between their feeding areas and their respective breeding areas. The Hawaiian Archipelago is important to humpback whales. It is the principal breeding ground for the North Pacific population. It's estimated that half of the North Pacific population comes to the Hawaiian Islands to breed. These days, it is estimated that somewhere around 12,000 animals come here. Many of them are Kama'aina whales returning to their birthplace, and a few new animals may arrive from other breeding areas. There are smaller subpopulations of humpback whales in the Western Pacific that breed in the Philippines and Okinawa and feed off Russia, and Alaska. In the Eastern Pacific, there are two populations of Mexico, the inshore population and the offshore population. And then there's an interesting other subpopulation that breeds off Central America. This is one location where it's possible that Northern Hemisphere humpback whales may meet Southern Hemisphere humpback whales. These whales may feed off the Western US and Canada. While humpback whales are here in Hawaii, they engage in a wide range of breeding activities. These can include competing for males, in some cases vigorously among the males, vigorous activity among the males, in some cases engaging in various types of displays, and for the females giving birth and rearing their young. One of the types of displays that humpback whales engage in is the production of song. Only males are known to produce song. All the males in the same breeding area generally sing the same song. The song is considered to be a very complex type of sound consisting of individual units, but it is also hierarchical. In which the units are organized into phrases, and multiple phrases are organized into themes, and multiple themes make up the song. I'm going to play a clip of a song, and we'll follow along with a pointer on a spectrogram. A spectrogram is a visual representation of the sound from low to high frequency on the vertical axis and how it changes over time on the horizontal axis. The warmer color means the more acoustical energy is, there's more acoustical energy, meaning that it's louder. A song lasts anywhere from 12 to 18 minutes, and a whale can sing the song multiple times, so singing sessions can last many hours at a time. The function of song has been debated for decades, and we will not get into the details of that today. There is agreement that song is a display of fitness, although we're unsure whether it's a display of the singer's fitness to a female or a display of fitness to male competitors. First one was a single whale, multiple whales, called a chorus. The sanctuary researchers engage in a lot of acoustic monitoring. Why monitor acoustics? First, whales sing and produce a lot of sound. Also, sound transmits really well underwater compared to in the air, about 4.5 times faster. In addition, sound underwater carries further than in air, meaning that we can hear what is going on better underwater than in air. Whale studies have shown when multiple whales sing, the volume of the singing is related to abundance. This is a spectrogram of a recording made in mid-December. These acoustic recordings are made using bottom-mounted acoustic recorders. In shallow water, they are installed by a diver. In deeper water, they sometimes have acoustic releases to bring them to the surface for retrieval. These recorders are installed for the entire whale season around November and retrieved at the end of the season. They record day and night, 24/7. The singing is monitored because it tells us when and where whales are present, and it tells us about abundance. These acoustic recorders are installed all along the Hawaiian Archipelago, not just around Maui. This is an example of chorusing data where there are, this is a record of the chorusing data off Olowalu, Maui, which is on the south shore. It's a shallow water site. And the variability of the lines indicate chorusing levels were varied. But why is there so much fluctuation in the chorusing levels? The answer is that beginning in 2015, beginning in 2015, there was a very strong marine heat wave off the Pacific Northwest, off Washington and Oregon, British Columbia, and Southeast Alaska. That was coupled with a very strong El Nino and a long-term cycle of warming called the Pacific Decadal Oscillation. These events combined to warm the waters in this area. This area, large area of very warm water, and formerly referred to as the blob, was significant and changed the wind circulation patterns, which changed the ocean circulation patterns. The ecosystem here almost completely collapsed. It affected our whales. There was a lot of whale mortality or whale deaths. Fisheries crashed, seabirds died off. It was a dramatic and chaotic time for the ecosystem in this large area. And this is where many of our whales typically go to feed and build up their thick blubber layers that allow them to live off the stored energy during their Hawaii migration. The fluctuations here is a direct result of the dire conditions of the blob in the northeastern Pacific. For Olowalu, the highest chorusing levels occurred in 2015. And has not been surpassed since then. The ecosystem disruptions occurred later that year and continued on until 2016. The 2015 season lasted longer than all subsequent seasons. So this would be number of whales, and this would be the whale season from December through May. So you can see that the whale season was the broadest when we had more whales in 2015. In 2018, the whales reached the minimum chorusing levels, and because of the corresponding decibel levels with whale, the correspondence of decibel levels with whale numbers, the researchers were able to calculate that 50% fewer whales returned to Hawaii in 2018 compared to 2015. That's a 50% drop in number of whales. In looking at the 2024 data, so that's this lavender line, the chorusing levels are intermediate, not as low as 2018, but not as high as 2015. It was similar to 2023, seeming to indicate that the population has stabilized the last couple of years. The fluctuations continue with an apparent shortening of the breeding season. On Maui, the peak of the whale season was usually in mid-February or March. These days, it's closer to early February to mid-February. We're seeing changes in the timing of when whales tend to be present and are most abundant here in Hawaii. The Hawaii data fits nicely with other data collected through other methods related to population. A research paper came out last year, authored by Ted Cheeseman and a lot of co-authors, including the sanctuary's researchers. All of the scientists and others, including citizen scientists, tour boat captains, and photographers all around the North Pacific, contributed whale fluke photographs. As you know, the underside of flukes is unique to each whale, much like fingerprints are to humans. This includes the coloration and the outline of the trailing edge, various nicks and scars that allow researchers to identify individual whales. Fluke photos taken at different locations are entered into an online database called Happy Whale that then uses very sophisticated AI tools to do fluke matching that used to be done by hand. Within a few minutes of submission of a fluke photo, Happy Whale can pull up the sighting history of an animal. It's a powerful tool. The map indicates the places where fluke photos have been contributed. This tool also allows researchers to estimate the abundance of whales based on when they were photographed. From this, researchers have learned that the population of humpback whales was on a steady increasing trend, recovering from decimated populations during the commercial whaling era, and now being protected by the Endangered Species Act, the Marine Mammal Protection Act, the National Marine Sanctuary Act, international protections, and others. So here's the increasing trend. It peaks around 2013 at about 35,000 humpback whales for the North Pacific population. Then it bottoms out at 2018. And then starts to creep up more. Prior to this time, the population was influenced by whether we were killing the whales through hunting. So when that largely stopped, the population started increasing. But now the population is limited by the resources that are available to the whales, which are largely driven by climate and oceanographic conditions. So we can see that this blob put a halt to this increasing trend. So this is the population trend for the North Pacific based on happy whale. This is the Hawaii subpopulation trends, and this is the Mexico subpopulation trend. The Mexico subpopulation has fewer whales than Hawaii. In Hawaii, there was a steady increase peaking in 2013 at around 17 to 18,000 whales. Then there was a really steep decline bottoming out about 2018. Now we're down to about 12,000 whales, 12,000 or so whales. Basically, Hawaii lost about 1/3 of its whales. The population trend is no longer declining and is leveling off. The Mexico population is steadily increasing and has not been affected like the Hawaii whales because these whales generally feed in other locations. The happy whale population data tracks well with the Hawaii coursing data. So let's move on from acoustic monitoring to some of the humpback whale behavior studies that Mark's team has been doing. While many of us have seen humpback whales in the wild, I'm assuming most of you have. Good. A lot of their behaviors are still poorly understood, even basic things like mating. We know that calves are born here, and working backward from an 11 to 12-month gestation period, mating has to be occurring in Hawaii. Even birthing is not well understood. There have been a few instances only in which partial birth was observed with the fluke sticking out. And later the whale was observed with a calf. Even these basic behaviors, with the thousands of whales here, the actual events are not readily accessible to us. Understandable, since many of the behaviors happen underwater and are not observable at the surface, since whales spend most of their time underwater. Or in some cases, some of these things might be happening at night, which has not historically been possible for us to observe. One thing to keep in mind is that all of these behaviors are taking place when the whales are fasting. We don't think that humpback whales feed in Hawaii to any real extent, although I'll be talking about that a little later. This means that the whales are on an energy budget. However much they feed in Alaska or other feeding grounds, that is what is in the tank, meaning that's the energy level that they have to expend until they can go back north to feed some more. That means that if they experience a lot of disruptions to their behaviors, that can come at a cost because they are on an energy budget. We study humpback whale behavior by deploying instrumented tags on the whales. These tags are very useful tools. They're attached to the whale via suction cups. These tags record a wide range of data, much like your own cell phones. They record sound, both the sounds that the whale makes and the sounds that it hears. It records movement such as speed, pitch, roll. It records dive profile. We can recreate how it moves in the water column. It also records temperature, light, and in some cases, video. The video feature has been a game changer. Historically, I'm going to show you a video in a bit. Historically, these tags have been deployed on a whale using a long pole and gently depositing the tag on the whale's back. Right? As you can imagine, not all whales appreciate being approached that close by a boat. This means that the tagged whales are only those which allow the researchers to get close.
Coming up, coming up.
In the last couple of years, researchers have adopted drones to deploy the tags. Whales are selected for study and the drones are flown overhead, then the tag is dropped. While the whale may know that something is overhead, most of the time after tagging, the whales just go back to what they were doing. The advantage of these tags is less disturbance to the whale, and it's safer for everyone since they don't get within 20 feet of a 45-ton animal. Researchers use the data from these tags to study a wide range of behaviors, such as communication, how they're using the sanctuary habitat, and how they react to exposure to noise. To you, right? Rather than here. Yeah. Okay. This video clip shows the camera feature on these tags. The tag was deployed on a yearling with its mother. The yearling is swimming under the mom, and mom adjusts the camera angle. And we have good views of the mother and a couple of male escorts. Mom. Oh, mom adjusted the camera angle. Mom and male escorts in the background. She's turning and showing her belly to the escorts. This is the mom. Oh, mom readjusted the angle again. You notice how the data is changing? Eventually, the mom and the calf settle down at depth. And just what Mark calls energy conservation or just relaxing, which is what most whales do in Hawaii. But you heard a lot of the sounds. That was not song. Those were social sounds. You get the difference between social sounds and song? Okay. That was the female making social sounds. And it would be good if you held your questions until later, if you can. Thank you. Using the videos, we want to know how the whales are spending their day. Does humpback whale activity level vary with time of day? Are they more active or less active during certain times of the day? If they are more restful at certain times, we might want to inform folks about that. One of the ways to analyze these data is by viewing all of the videos and rating their behaviors on a scale of 1 to 4. 1 being a stationary time. Simple straight line swimming is number 2. 3 is a more complex swim, perhaps with another whale. And then level 4 is the physical engagement, where there might be really aggressive behavior and perhaps some male competition. There seems to be really clear patterns on average. For example, stationary behavior, which is the blue on this chart, seems to increase in the afternoon. The red bars on this chart is simple swimming. There's a lot of simple swimming in the morning, and it hits a low between 1 and 4 p.m., then increases again. Surface behaviors on the right chart, the blue bars, indicate they're taking few breaths per hour in the afternoon and less surface activity with the red bars in the middle of the afternoon. See the story, right? Similarity. The whales seem to rest more between 1 and 4 p.m. This is important information because maybe we need to be more mindful of the whales at that time and give them more space. Historically, we have very little information about whale behavior at night. The videos just show black at night, so they're not useful. The other sensors on the tags allow us to look at behavior such as depth of the dive, how often they breathe, speed, and duration of the dive. There seems to be some sort of behavior shift right around sunset. Generally, a spike in behavior just after sunset. There's not much data beyond midnight because the suction cup tags usually fall off by then. So we are trying to get more data for the entire night. Does the increase in activity after sunset indicate more male competition then, more mating activity? We don't know at this point. We're especially focused on how humpback whales relate to vessel noise, not only in Hawaii, but elsewhere. They come in constant contact with vessels, and their response to vessel noise can vary a lot depending on the circumstances and what they are doing. It's not clear-cut, and it depends on what part of the world you're in and whether the whales are used to the sound or not. Researchers from Australia have demonstrated that mom and calf pairs do avoid loud vessel engine noise. In Japan, researchers were able to show whales would stop singing if the ship came too close. Australia found that vessel noise did not seem to affect singing behavior. In 2018 off Maui, the researchers lucked out in having an opportunity to study a singing humpback whale's response to boat engine noise. At about 10 a.m., soon after a male humpback whale was tagged, it started to sing for about 4 hours. After 1 p.m., a tug towing a young brother's barge happened to pass within 400 yards of the singing whale for about 20 minutes. Researchers on the research boat noted that the whale continued to sing, but they decided to look more closely at the data on the tag. The dive profile indicates that the tagged whale did a series of about 20 dives and sang while diving. So the singing part is this teal part, and these are the dives. The barge could be heard during 3 of the whale's song cycles. Although the whale continued to sing, his dive pattern was more erratic, especially around song 12. The dive depth during which the tug could be heard was much longer and more variable than the dives before and after the tug engine sound was noticeable. The movement of the whale was quite consistent before the tug noise and after the barge passed, but more varied when the tug was in transit nearby. So consistent, but variable. This shows the whale movement change in response to the noise from the tug. What is really interesting is what happened with the singing. Consistent whale song before and after the tug engine noise, but more disrupted when the engine noise was heard. Remember, we talked about the construction of song units, phrases, themes. So these are units of song. And so notice how it's kind of consistent. Then something happened up here. There were new units, new sound units developed, and songs 11 and 12 were shorter in duration. There's some more new song units. This chart shows the phrases, and you can see that totally new phrases were produced. At song cycle 14, the whale just went back to, after song cycle 14, the whale went back to resume its regular song. Mark jokes that perhaps this is what whale cursing looks like. The bottom line is that the responses that were observed in Hawaii on Maui was intermediate between what the Japanese researchers observed, which is the whales stopped singing and left, and the Australian researchers reported that they kept singing. In the Maui case, the singing was clearly disrupted both behaviorally and acoustically, but it did not stop, and it returned to normal once the disturbance passed. What this reveals is that the whale's responses to these disturbances can be nuanced and temporary. Oop. The whale's reaction is deserving of more attention by Hawaii researchers. Last season and this season's collaboration with other researchers in Hawaii and on the mainland involved tagging whales with drones and playing simulated vessel noises and determining at what decibel level is there an obvious response. In other words, at what point does a whale get bothered by whale noise? The videos have produced some unexpected results. For example, the surface behavior of a competitive group was recorded by a whale watch boat off Maui. A competitive group consists of one adult female and multiple males. Historically, we have always assumed that the males are fighting or competing with each other until there's one dominant male that then has exclusive access to mate with the female. The significance of this video is that it introduces the idea that perhaps the mating strategy is not so clear-cut. Basically, this video shows whales on top of one another. Is this how mating happens normally, or is this rare? The question this raises is whether humpback whales are polyandrous species. That means that females mate with multiple males. We have been assuming that females select one male. It's her choice, she decides. The video suggests that she does not choose, and the competition is no longer a male against male competition and is instead a sperm competition. This kind of competition does happen among other whales, such as right whales, so it would not be unique to humpback whales. If this is not mating, is this male aggression? And what is driving the aggression? Questions on the reproductive strategy on humpback whales are being raised. So the next couple of videos I'm going to show you is about feeding in Hawaii. And just for orientation or a reminder, humpback whales use their big mouths as giant scoop nets. And they don't have teeth, they have baleen that hang from the top of the whale's mouth. So here's an example of real baleen. So there are hundreds of these lining the top of the whale's mouth, shorter in the front, longer in the back. And there's a frayed edge, and this frayed edge is on the inside. So compared to Hawaii's ocean, the waters to the north are way more productive in terms of having a lot of things for seabirds and whales to eat. So these are millions of shearwaters. Maybe some of our killer whale shearwaters are over there, right? So humpback whales and shearwaters feeding up north. They feed on krill, small shrimp-like animals, and small schooling fish like sand lance and herring. The interesting thing is they can hyperextend their lower jaw. So most of the time, the upper jaw and the lower jaw fit into each other like this. Right? That's my model. But take a look at this. See how the lower jaw is hyperextended? So now it has a super net, right? A super scoop, fish scoop. Okay. So just a couple years ago, while the sanctuary boat was out trying to tag whales, they saw a couple of whales in the distance and thought they would be good candidates for tagging. But they noticed something else. They noticed a whale doing feeding lunge. And a bunch of times it did the feeding lunge. And they also noticed that a bait ball was in the water as well. So I'm going to play the video. At this point, they don't know what's going on. So he's pointing to a bait ball. Feeding lunge. So bait ball is a school of really small fish, bait fish. So you can see the fish. Okay. We thought it was pretty unique, but a week later, a social media post of a helicopter tour of Molokai showed a whale taking several feeding lunges off another bait ball. Feeding lunge. So, do whales actually feed in Hawaii? Apparently, yes, but it's likely quite rare, as there have been only 2 recorded observations in decades worth of whale research. Is it driven by unknown factors such as, was the prey unusually abundant that year? Or were the whales food stressed and really looking for food and feeding wherever and whenever they can? Was this random luck and this happens perhaps more frequently than we thought? What is the prey? Or is it something, is it nehu or is it something from the depths? Does it happen more at night? The whales obviously cannot sustain themselves in Hawaii year round. Otherwise, they would be here longer. Mark and team published a paper last year on humpback whale feeding and pooping in Hawaii. All of the team's publications are available on our website, hawaiihumpbackwhale.noaa.gov under the research tab. So we talked about, or we showed how humpback whales are taken from the Hawaiian environment, but they also contribute to the Hawaiian environment. Fish like to eat whale skin. The sloughing of the skin happens more readily than human skin. During the videos, did you notice all that, those flaps? Okay, that's whale skin. Normal. It's not, doesn't have a condition, that's normal. Okay, and so it provides food for fish. The mortalities provide food for the Hawaiian environment. When they reach the bottom of the ocean, it's called a whale fall. Some of the birthing liquids in the placentas provide food for the environment. And because we're in warmer waters than up in Alaska and other places, the barnacles usually fall off here in Hawaii. And in addition, there's whale poop that contributes. Fish like to follow calves, and the mom-calf relationship is very physical. So you see that, it helps sloughing, the skin sloughing, but the fish follow the calf similar to a family dog under a toddler's high chair. So this is about entanglement. And they sometimes bring their entanglement with them from the northern fishing areas. And this male is with a female and a calf. And you can see the entanglement here. So here's up in Alaska and some other areas, the fishermen tag their gear. So their buoys and everything have a code, a numerical code or alphanumerical code. So when we see them here in Hawaii, we're able to track and find out whose gear it was up north. And so these are actual confirmed gear from up north that was then sighted or taken off a whale in Hawaii. The advantage of us doing the whale rescue or the response to whales in life-threatening entanglements is that up north, they're up in deeper water and they're quite dispersed. Here in Hawaii, they're in a relatively shallower water within a few miles from shore. So it's easier for us to access them. But some of that gear consists of traps or pot, crab traps, other things like that, quite heavy. So here's the drone being deployed by the tag being deployed by the drone. And it helps us better understand how the whale is entangled and what kind of gear it is. So this allows us to strategize how to help the whale and to use the proper tools to cut the entanglement all off. So as you can imagine, an entanglement through the mouth is quite devastating. This perfect alignment of baleen could be disrupted, right? Going in different directions. And then the whale won't be able to efficiently feed. So in the long run, you know, it's a life-threatening situation. Here we're using a tool at the end of a very long pole, and he was successful in cutting the entanglement. With mouth wraps, what they're calling mouth wraps, if you make one cut, usually the drag on the remaining part will eventually work the line through the baleen, and the animal will be freed. So this is not something for anybody to do, and certainly I don't want to hear that anybody has gone into the water to try to save the whale like that. The entanglement response that we do is authorized by NOAA Fisheries. It's done by trained folks, and it's boat-based. Nobody goes into the water. People have gotten killed trying to save a whale. Okay. Not here. We're trying to learn from that so that we're safe. So let's talk a little bit about threats to humpback whales. Certainly climate change, and we talked about, you know, the numbers being reduced because of the blob. But the whales are not finding food in their normal feeding areas. So they're having to expend energy to find more food. One of the problems is the food is not as nutritious as it used to be. So they need to eat more if they can find it. So we're finding that some of the whales may decide to stay up north rather than come down to the breeding area, because remember, when they come down to the breeding area, they're fasting. So if they don't have enough energy in their energy tank, they're going to have a hard time coming down, you know, migrating a month, staying in Hawaii, and then migrating back for a month. So it's very taxing. Collision with vessels is a problem, as is entanglement in fishing gear and marine debris. And then we humans are a big part of this one here, in which we are clamoring to get closer to the whales, or pressuring the tour boat operators to get closer to the dolphins and closer to the whales, so people can have a, you know, what they think is a better experience. There's also, you know, impacts caused by vessels that are used for oil and gas exploration, military activities such as Navy sonar, and explosions from trainings and exercises. But all of these things are taking place all around the world, not just in Hawaii. There are many things that that we can all do to help reduce the threats of humpback whales. And here's just a partial list. Please do what you can. As the research has shown, these humpback whales are still vulnerable. Mahalo for your attention, and to all of the folks who collaborated in the research and the presentation. Mahalo. And we'll take questions from the live audience. Is that how you want to do it? Okay, so people online, can you put your questions in the chat? Do you have any questions here? Yes, Hop? Yes. So there are three countries that are hunting whales: Japan, Norway, and Iceland. I know Japan was saying that they were doing it for research, but there are remarkable ways to do research without killing them. And so we, of course, use the non-lethal methods. They do have it on the fresh meat market, and they also can whale meat.
Gene, does that also include humpbacks? They're killing whatever whales they want?
Yeah. So
Uh-huh.
from some of the video that I've seen, they seem to be harvesting mostly minkies, which are baleen whales, but smaller than humpbacks. But I understand they're also taking humpback whales as well, too. Yeah.
I have two questions. One, those monitors you put on the ocean floor during the season, you said you put them in November and take them out later. Do you have access via computer for readings throughout that season, or is it collected post-season?
Yeah, it's collected post-season.
Okay.
Yeah.
Didn't want to assume without checking. And secondly, crazy high surf, Kauai-wise anyways, prevents us from being able to be in and observing, right, boats, dangerous situations. Is it possible the birthing is coinciding with the whales knowing that we're not near them by boat or humans in the water? You know what I mean?
I don't think so.
Okay.
The highest density of whales during whale season is off Maui, Molokai, and Lanai, the Maui Nui Islands. And so the lee of those islands is quite extensive. In addition, the water is shallow among those islands. So the whales are, we find the lee, especially the females that are giving birth or have a young. They're in the lee in shallower water, perhaps in bays.
Okay.
That doesn't mean that you should go with your kayak and get close to them. You know that we have the 100-yard approach regulation, right? Yeah. And then I heard sometimes people they try to play song to get them to come closer. That's not allowed either. Okay. The playback that the sounds that the research team will be doing is fully authorized. People are not allowed to introduce sound into the whales in their environment. It's not allowed.
What are the consequences if people are caught doing so?
Well, I just know that within the sanctuary boundary, the penalty, the civil penalties are higher. Yeah.
You mentioned that there might be a meeting of the Pacific whale and the North Atlantic whale population off the coast of Mexico.
Off the coast of Central
Of
America.
Central America. Well, we'll assume that they haven't swum through the.
Does that mean that they actually go the way down? No, I don't. Okay. I'm not sure if maybe I made it clear enough. So, and I'm sorry I don't have a map. I don't have a map. Okay. So, yes. So I'm not saying Eastern Hemisphere and Western Hemisphere may meet. It's Northern Pacific Hemisphere and Southern Pacific Hemisphere. The whales from those places may meet. So they're not going around continents. Right. Okay, no, thanks for asking that.
Suction cup that you put on, the suction cup, you're saying they didn't see they come off the day or so? But you also do more permanent things?
We sometimes, no, the researchers sometimes do help with some experts who do satellite tagging of the whales. But that's an invasive procedure. So basically the satellite tag could be like a pen. And so it's inserted into the whale. We don't normally do that. We do non-invasive procedures. Yeah. But there are other ways to do it, yeah. We also sometimes do get samples of whales to get information about maybe the toxicity level of the blubber, to measure hormones of females and other things like that, stress hormones and stuff like that. That is done using a crossbow with a hollow point on an arrow that only gets maybe a pencil eraser size piece of skin and blubber. So the reaction from that has been not bad. But yeah. Thank you. Question? Don't make it a hard question.
I have really great questions online.
Oh, wow, okay.
There seems to be more sightings of whales on the south shore of Kauai than the north side. Why would that be?
Are you talking about in general or are you talking about ocean count?
I think it's probably in general.
I wouldn't necessarily agree with that. Remember, when you're watching whales from shore, you can be affected by wind, by whitecaps, fog, all kinds of things. So the ocean conditions, the weather conditions do affect our whale viewing conditions. There may be more people watching from the South Shore, meaning Poipu area, perhaps. And perhaps the North Shore, especially lately, has had some tremendous, huge waves. So I don't necessarily agree with that.
Okay, perfect. And then can you go back to the page that you had about volunteer opportunities and leave that on the screen so folks online can jot those down?
Are you talking about this one?
Yes.
Yeah.
And then another question, is there ever humpback beaching problems in Hawaii? And do they have any theories on why the whales beach?
Breach or
Beach.
strand?
Strand.
Strand. Okay. Well, I think it was 2 or 3 weeks ago, there was a calf that stranded off Kihei Maui and later died. I don't believe they know what the cause of death was. But the thing about whales in general is that they have, especially humpback whales, they have a blubber layer, right? So they're quite buoyant. But when they're sick or injured, they're not as buoyant. Okay. So their breathing is from the blowholes up here. So if they're not as buoyant and they're kind of sinking, then their blowholes are getting covered with water. So the tendency is then for them to come ashore to keep their blowholes open. Okay. But it could be a number of things that might be wrong with the whale, or for some species that travel in pods, such as small fin pilot whales, if one member is sick, the others are so closely attached to that they'll all come into shore. So there might be 200 whales, but only one is sick, but many of them will come ashore and get into trouble. Because once they get on to the beach, they need the water to float themselves, right? And so all of that gravity causes injury to the internal organs. There are some whales that are born with birth defects, and we've seen that in Hawaii sometimes as well too. It's like the whale spine is curved. Could be all kinds of things. Normally, calf mortality is almost 20%. Okay, almost. So if we have, let's say, 100 calves born this season, about 20 aren't going to make it anyway within the first year, yeah. So it's kind of a tough life, right? Yeah.
If we're out on the point and one day we see lots of whales and the next day we don't see any, once they come back to say Kauai, are they traveling around the island, or they tend to stay in the same areas, or?
They're highly mobile for the most part. Maybe moms and calves might hang around an area more, but for the most part, they're highly mobile. So they do go around Kauai, maybe sometimes several times. They do go to Niihau. They do go between islands. So one whale that might be seen off Kauai today might go to Oahu and then end up on Maui. Some big island whales also go between islands. So we know that because whales that are in life-threatening entanglement, if we can't get to them right away, we attach a buoy to the entanglement, and the buoy has a satellite tag. So we're able to see the movement so that when the conditions are better, we can respond with the entanglement team. But within the course of a day or a couple of days, they can go to a couple islands, three islands. Okay, we were talking about just regular traveling. Were you talking about coming back to the birth spot?
Not necessarily.
Yeah, they're highly mobile. Yeah.
So I work at or volunteer at the lighthouse, and last year and this year, I've twice observed this behavior, and I am curious about what you might think it means. So it's always a mom and a baby. There might be another whale around as well, but it's always a mom and a baby. And I think it's the baby that will like repeatedly slap its tail like 25 times deliberately, repeatedly, not just random not, and so I'm just curious as to what you might surmise that would be. Because there's no predators around, so it's not a warning of some sort, but is it just the baby learning how to do this or?
Well, you know, there's a
No
lot about
idea.
whale behavior we don't know,
Yeah.
right? So the slap is very percussive, right? So
Right.
the sound carries quite a bit.
So
It could just be having fun.
fun and making noise.
It could be imitating the mom.
Yeah. just so
I wouldn't
deliberate.
say
It's-
that at that age that it's related to mating behavior or getting at predators.
Yeah, and I can't say if it's the baby or the mom that's doing the tail slapping because it's kind of far away. You can't see the size so much. But last week, it was then followed by the pectoral fin, and that must have been about 10 times. So
So you don't know whether you're talking about
times, and then we did the pectoral had to have been the adult because it was large.
Okay.
So, but it was just.
I thought you were talking about the
bizarre.
whale doing the
whale-
calf doing the.
I can't tell if it's the calf or the mom.
Okay, it makes a difference, I think, if it's an adult or a calf we're talking about. You know, the calves, when they're born, they're quite, what can I say? Some of them need help. So newborn calves sometimes are carried up to get air on the rostrum or the head of the mom. And, you know, learning to, you know, maneuver. So the calf that was doing the tail, if it was the calf doing a tail slap, that would have had to been not a newborn. At this point, I'm not sure if the calf would have recognized a predator. I would say that the adult doing a tail slap might be communicating in some way, just
Yeah,
like
if
peck
it was
slaps.
the adult doing it repeatedly, that would just be communication or something to the baby.
Or to other whales as well,
With other
too. They're
whales.
not just, the pair of them might be
Yeah.
with other whales as
It's
well,
just-
too.
Like I said, I've observed it twice, 2 different years, and it was a mom and baby both instances. Couldn't really tell if the tail slap, who was doing the tail slap,
Yeah,
but it was very deliberate.
yeah. Yeah. Okay. Hey, thank you so much. Nice seeing all of you.
One more question.
Yeah.
How long does it take for a humpback to get full grown?
Males mature slower than females. So generally, I think females can become sexually mature at 5, and maybe males at like 7-ish, something like that. But you know, I've had to change what I know about so many things that I don't even know if that is true. Because if they're having a harder time finding enough food, maybe the growth rate is less. Maybe it's taking long, you know, maybe, I don't know. But that's my blob answer. Right? Life is distinguished between pre-blob and post-blob, just like pre-COVID or post-COVID, right? Yeah.
You had mentioned that the perception of how the mating activity happens might be different than you thought. You thought it might be males competing for exclusive mating rights with a female. And then you mentioned it could either be the behavior that you saw in that video, males competing, or sperm competition. What is sperm competition?
Okay, I'm looking to see that we don't have, we have only adults in the room, right? Okay. So, so what we thought was happening earlier is that female can be in a group with maybe 10 whales, 1 female, 9 males. And so the thinking was that the competition would be between the 9 males who would then have, you know, the best chance of mating with the female. But the video that I showed, and there's some others that I couldn't show you, but the video I showed, at the surface, you could see all kinds of things happening. Beneath the surface, I've seen videos of what that was. And the boy parts of the male were out. And so they might be taking any opportunity to mate with the female. So the competition then would be in the deposited sperm in the female. It would be a sperm competition as opposed to the physical 9 whales competing against each other for, you know, being close to the female. You get what I'm saying?
So there could be multiple deposits in whichever.
Yeah. Yeah.
That's what I thought.
Yeah.
We wanted to hear you describe that.
Well, you know, okay, you know, local girl talking about these things took me a while to figure out how to say stuff, you know?
Way to use
Yes.
your yards.
But thank you for expressing it that way. Yeah.
Any other
Okay.
questions? Jean, roughly how many entanglements would be cleared per season by the team? Is there any average numbers you could share?
I just heard Ed Lyman, the lead for entanglement response. I think he said the average was about 14 per season here in Hawaii. And I think he said the number right now is up to 8.
This season?
Okay, but we don't know whether it's going to taper off. We don't know if there's something happening in the environment or what. Yeah. So, but it's remarkable work. And they don't just cut the whale free of the entanglement. They try to get as much of the entanglement as possible so they can analyze how the whale was entangled. And, you know, the whole idea is to try to prevent something from happening. Anyway.
Autopsies of the humpback that are showing that in their feeding grounds, they're getting plastic into their bellies.
I haven't heard of that yet. I do know that, you know, remember I talked about getting the toxicity levels of the blubber. The humpback whales don't have much of a toxic load as maybe do killer whales because humpback whales feed at a lower level. Okay, so they're into krill and small schooling fish as opposed to eating marine mammals. And by the way, they're into small schooling fish. So they're, if they see a mahi-mahi or an ulua swimming by, it's not going to think that that's food. It's not going to see you in the water and think you're food because their throat, even these big animals, their throat is small. So they would choke. Yeah, if they went after some big stuff. Yeah.
Jean, could you remind us of the hours of when we could see you at Kauai Ocean Discovery?
Oh, yes. So I hope you can visit us. It's a free ocean learning center. It's at Kukui Grove Center in Lihue. We're open normally after school Wednesday and Fridays, 2 to 5. And then on weekends, generally Saturday and Sunday from 11 to 2. Yeah.
Thank you. My goodness, what a wealth of information. Thank you
Yeah,
so much.
thank you.
Thank you.